Hello everyone, in this video let us visualize Fourier series. What is Fourier series? It represents a periodic function with the frequency omega as a sum of sines and cosines whose frequencies are integer multiples of omega. Most famous example is a square wave which has either 0 or h in two intervals minus pi to 0 and 0 to pi. So Fourier series expansion looks something like this: an infinite series, a DC term, a multiplier, and then we have sin x, sin 3x, sin 5x, and 1 by 3, 1 by 5, 1 by 7, that is 1 by n is the coefficient. So in this visualization I'm going to visualize the sum as a function of number of terms. What do I mean? If it is one term, then it is up till here, that is h by 2 plus 2h by pi sin x. If it is two terms, it is h by 2 plus 2h by pi into sin x plus sin 3x by 3, so on. 3 terms, 5 terms, 10 terms, 100 terms, like this we are going to visualize. So this is a sum of periodic functions with a period of 2 pi, square wave, sawtooth wave, full wave, and a triangle wave. So this is just a brief introduction, just to give an idea of what it is, so that the visualization becomes easier. I suggest further reading of undergrad textbooks or internet resources for complete information. Let's look at this visualization window. First we can select a function of our choice. Let us check a square wave. A square wave looks something like this. Height is relevant only to square wave. Nevertheless, we put only one. Number of terms we want to add. As a starting point, let us take only 5 terms. This is time between display of two different series. Let's put it as 5 seconds, and then let's calculate. And then this is how it looks. This blue one is the actual square wave. Now this is after 2 terms. After 2 terms, the Fourier series looks like this. We don't have to look all the way. We can concentrate in any one of the regions. After 3 terms, 4 terms, and 5 terms. So this is what we see in textbooks. Here are the coefficients here. This is with sine. There was only sin x, sin 3x, sin 5x, sin 7x, and sin 9x in this visualization. And there are the coefficient, the multiplication factor before each of the sine terms. First is 1, 1 by 1, 1 by 3, 1 by 5, 1 by 7, and 1 by 9. Now when we look at Fourier series, two things to look for. One is how the function looks like here, and how close is it to this region. So as the number of terms increases, the gap between dashed line and the continuous line diminishes, and the number of these ups and downs will increase. So let us look at this. Let's put 100 terms and make it very, very fast. Let's start. So you can see after 100 terms it looks like this. Here it is almost covered, and there are some spikes. After each pi there is a spike. You can read in textbook what it means. This happens for square wave and a sawtooth wave. So it appears as if this has reached, but if we zoom in, we'll see that still there are undulations. For that, let us zoom in and see. So observe here I'll be plotting this particular region. So you can see after 100 it appears as if it is flat, but if you zoom in, you will see that still there are undulations. So if you increase further, let's say let me put 1000, and then observe what happens. 100, 200, 400, 500, 600, 700, 800, 900, and 1000. So after 1000 it almost flattened out. but small undulations will nevertheless be there. So here it has flattened, but coming close to this discontinuity we'll still see. But remember the scale, this scale is minus 0.02 to plus 0.02. 1 2 3 4 5 6 7 8 divisions within 0.04. So this is that small. Now let us observe individual terms one by one. So this is a square wave. I am plotting only one cycle, and over here this is the first term, that is the sin x. So you can see the first term is needed like this. This is after second term. Now two extra undulations have come as if it is bending now. After 3 there are 2 bendings here and 3 up, that is 3 peaks and 2 valleys. So now 4 peaks and 3 valleys. So it is like one wave is adding in each of the additions. So this way we can see the distance between each peak is reducing, and when the number becomes very high, let's say 100, then there will be 100 peaks and it becomes almost flat. 50, 100. Also we can see here the individual terms. This is 1 sin x. Now you can see the contribution has decreased, sin 3x by 3. This green one, sin 5x by 5. So the coefficient is also important. The exact coefficient and the exact sine term will lead to a desired form. Now let us do something interesting. Let us see how, let's say this is first term, this is second term. Now how this second term is generated? By adding this term to the first term. So the idea is to see how this function is generated after two terms. So we will display the first term and then we will add second term to the first term and see that each position what happened. So this is the first term, green one. This is the second term, and then adding these two terms we will get this term. So it will be clear once we reach this region. I'll narrate. So this graph changes color depending on whether the second term is greater than the first term or less than the first term. It is red now. Now it has become blue because this is negative. The second term is negative, hence the entire graph will be shifted with respect to the first term. Now the second term is positive, so it gets added up at each of these points. The total sum will be more than the first term. It will happen until this point. Now after this, the second term is negative, so the total sum after two terms will be less than first term. So you can see this is the first term and this is after two terms. It is so this how the third term will go up down on this. So there was one valley and one peak, and after addition of sin 3x it became one peak and two valleys. So do we generate periodic functions using the Fourier series? We have taken different examples, particularly focusing on a square wave and generated square wave by adding different terms. We also saw the zoomed thing and saw that there are variations. If you zoom in, these are the individual terms, and then the coefficients will decrease as a function of the number of the term. Thank you for watching this video. Hope you enjoyed this. Thank you very much.